Hello everyone, my name is Dr. Vile and welcome to my A-Level Chemistry YouTube channel. The purpose of this channel is all about getting you ready for your A-Level Chemistry exams, and this video specifically is going to look at a topic called enthalpy of solution, which is on the A2 chemistry syllabus. And basically what this is all getting at is, will ionic compounds dissolve in water? So at GCSE level you will have been taught ionic compounds are soluble in water. What I want to say is that ionic compounds are generally soluble in water, but not all of them are, and we're going to have a look at why that is the case. So we're going to look at the process that occurs when an ionic compound dissolves in water, and we'll try and relate it to enthalpy values and do some calculations to prove whether a solid will dissolve in water or not. That's what this video is all about. If you find it helpful, remember to like, subscribe, and keep checking back for more content. Okay, so let's take sodium chloride as an example. Sodium chloride, NaCl, one sodium, one chlorine, and it exists as an ionic lattice. I've shown it here on the left-hand side of the screen. You've got this cubic lattice of repeating sodium ions and chloride ions in a nice cubic structure. And the ions are held like this so as to maximize the amount of attractive force between opposite charges and to minimize the amount of repulsive force between like charges. And when you dissolve an ionic compound, you basically got to smash up this lattice. We call this the enthalpy of lattice breaking. You've got to break open the lattice to give you the gas phase ions. So the first thing that happens is you take your NaCl solid and you smash up the lattice to give sodium ions, Na plus, gas, and chloride ions, gas. Now that process there is very much endothermic. It requires energy to smash up the lattice. And then once you've got your gas phase ions, you need to hydrate them. You can see them in this picture on the right hand side. So here's the chloride ion here, this one here, and it gets surrounded by water molecules. Remember, water is polar. It's where the hydrogen is delta plus. So the delta plus hydrogen is attracted to the minus chlorine and it gets hydrated. So the chloride ion gets surrounded by these water molecules, more specifically the hydrogens of the water molecules. This process is exothermic. It releases energy. And the same is true of the sodium ion. The sodium ion gets surrounded by the water molecules, more specifically the oxygen of the water molecules, because it's delta minus, so it gets hydrated. So you take your gas phase ions, so like the Na plus gas. My mouse isn't working brilliantly on this one. I don't have my mouse pad, so my writing's looking a little bit rubbish. So you take your gas phase ions and you hydrate them. So you'd still have Na plus, but it would be aqueous. And then you've got your chloride ion, which would be aqueous. So these are the two steps involved in dissolving sodium chloride. Number one is you break apart your lattice. So this is the enthalpy of lattice breaking. And remember we said that this is endothermic. And then once you've got your gas phase ions, you come across step number two. And that's where you take the gas phase ions and hydrate them to give aqueous ions. This is the enthalpy of hydration because you're adding water, and this is exothermic. And basically, you take the values for the endothermic step and the values for the exothermic step and decide which one's bigger. So if the exothermic step is bigger than the endothermic step, then the ionic compound dissolves in water. And if the exothermic number is smaller than the endothermic number, then the compound won't dissolve in water. But it's easier to look at some examples with that. So let's take the ionic compound silver chloride, AgCl. Now, if you remember back to the silver nitrate test where you're testing for chloride ions, Silver chloride is the precipitate that forms, and the fact that it's a precipitate tells you it's not soluble in water. So we would expect this compound to not dissolve. So firstly here we've got the values for the hydration of the silver ion and the hydration of the chloride ions. These are both exothermic. And then on the bottom here you've got the standard enthalpy of lattice breaking for silver chloride, which is endothermic. The equation that you want to learn for this is given here in this box. Delta H sol, the enthalpy of solution, is equal to the enthalpy of hydration plus the enthalpy of lattice breaking, where delta H hydration is going to be exothermic and this is going to be endothermic. So in this case it's minus 464 plus minus 364. That gives you your enthalpy of hydration. Then you add the 905, which is the enthalpy of lattice breaking. That gives you a value of plus 77. Now if delta H sol is positive, that's a really good indicator that the compound is not going to dissolve in water. And if delta H sol is negative, that's a really good indicator that it will dissolve in water. And because it's a positive number here, it's insoluble as the process of dissolving is highly endothermic. Now, this isn't factoring in entropy, but it's a really good indicator. Okay, so let's take calcium chloride as a second example. Calcium chloride has the formula CaCl2. So that consists of one calcium ion, which is minus 1591. And then you've got two chloride ions. That's going to be two lots of minus 313. And that'll give you the enthalpy of lattice hydration. Let's just put that all in brackets. And then you've got the enthalpy of lattice breaking, which is plus 2195.2. So it'll be plus 2195.2. And if you put that into your calculator, it comes out as minus 21.8. And that would be kilojoules per mole. And because it's exothermic, that's an indicator that calcium chloride is going to be soluble in water. As a side note, but very important, the more exothermic the value, the more soluble the compound would be. So if you were comparing two ionic compounds and one had a value for delta H sol of minus 50 and the other one was minus 100, the compound that was minus 100 would be more soluble than the compound that's minus 50. Anyway, that's hopefully a little tour then of how we can work out whether a compound is going to dissolve in water or not. We take into account the two processes. You've got the lattice breaking and the enthalpy of lattice hydration of the ions being hydrated in water, and you add them together basically. And if your final answer is exothermic, that's a sign it'll be soluble, and if it's endothermic, that's a sign that it will be insoluble. So I hope that was helpful. If you found the video helpful, remember to like and subscribe and keep checking back for more content. See you next time.